Today we are going to learn about sequences. Have your notes out in front of you so that you can follow along with this PowerPoint. Let's see what you already know about sequences. Look at the first three examples on your notes and see if you can describe the pattern and then write the next three terms in each of the sequences. Okay, let's see how you did. For the first one, you should have written that you are adding 1 apple each time. So the pattern would continue with 4 apples, then 5 apples, and then 6 apples. For B, you are adding 4 each time. So the next three terms in the sequence would be 19, 23, 27. For C, you are multiplying by 2 each time. So the next three terms would be 32, 64, 128. A sequence is an ordered list of numbers, pictures, letters, geometric figures, or just about any object that you like. So the first three examples that we just did were all sequences. Each number, figure, or object is called a term in the sequence. For convenience, the terms of sequences are often separated by commas. Each term's index is its placement. So you have the first term, which has an index of 1, the second term has an index of 2, and so on. Let's look at the sequence 10, 20, 30, 40, 50. The number 10 is the first number of the sequence, so its index is 1. And the number 40 is the fourth number in the sequence, so its index is 4. So you try. Look at the sequence 12, 15, 18, 21, 24. What is the index of the number 15? So in this example, you would look for the term 15. Since it's the second number in the sequence, the index is 2. The notation for the term of a sequence is a sub n, where n represents the index or the placement of the term in the sequence. So if we look again at 10, 20, 30, 40, 50, we can write a sub 1 equals 10, since the first term is 10. A sub 2 equals 20, since the second term is 20. A sub 3 equals 30, since the third term is 30, and so on. So now you try one. Look at the sequence 12, 15, 18, 21, 24. What is a sub 4? This means that we're looking for the fourth term, so you should have gotten 21. Alright, let's look at two more examples. 5, 4, 3, 2, 1. First, see if you can describe the pattern. You should be able to see that this is decreasing by 1. A sub 4 means we're looking for the fourth term of the sequence, which in this case is 2. A sub n equals 5 means we're looking for the term 5, and we want to know what the index is. So we find the number 5 in our sequence and see that it's the first term, which means that n would equal 1. Let's look at a second example. 3, 5, 1, 2, 4. For this example, there is no pattern, which means that this is not a sequence, but simply a list of numbers. In order to be a sequence, there would have to be some pattern. A sub 5 means that we're looking for the fifth term in the list. So in this case, the fifth term is 4. A sub n equals 5 again means that we're looking for when the term is 5. And since the second term is 5, n equals 2. Alright, so now you try the next two on your notes and then we'll check to see how you did. Alright, let's check your answers. For C, you should have seen that the pattern was that the sequence was increasing by 1. A sub 999 means we're looking for the 999th term, which in this case is 999. A sub n equals 1000 means we want to know the placement of the term 1000, which is the 1000th term. In D, you should have seen that we are multiplying by -2. A sub 4 means we're looking for the fourth term, which in this example is -8. A sub n equals -32 means we're looking for the placement of the term -32. To solve this, you would have needed to continue the sequence, and you could see that n equals 6. We can write a formula for the sequences using a recursive definition. If a sub n represents the nth term, then a sub n minus 1 represents the previous term. It also is very important that we list the first term each time we write the formula. So let's look at an example. Consider the sequence 5, 3, 1, -1, -3. The pattern is that the sequence is decreasing by 2 each time. So to write the recursive form, we would first need to say what the first term is, which in this case is 5. And then we can take the previous term and subtract 2 every single time to get the next term. So we would write a sub 1 equals 5, and a sub n, which represents any term, is equal to the previous term, written a sub n minus 1, minus 2. Let's look at another example. 1, 2, 4, 8, 16. Each term in the sequence is being multiplied by 2 to get the next term. So when we write the recursive form, we could write that the first term is 1, and to get any term in the sequence, we would take the previous term and multiply it by 2. So a sub 1 equals 1, and a sub n equals 2 times a sub n minus 1. Okay, so let's try some more examples. See if you can write the recursive rule for each of these sequences. And be careful, don't forget to write the first term every time. Okay, let's check your answers. For A, the pattern is that we're multiplying by -4 each time. So you would write a sub 1 equals 1 and a sub n equals -4 times a sub n minus 1. For B, you're adding 3 each time. So a sub 1 equals 3 and a sub n is equal to a sub n minus 1 plus 3. For C, we are subtracting 4 each time. So a sub 1 equals 17 and a sub n equals a sub n minus 1 minus 4. For D, we're dividing by 2 each time, but we always want to write our recursive form using multiplication or addition or subtraction. So since we're dividing by 2, this is the same as multiplying by 1/2. So we can write a sub 1 equals 80 and a sub n equals 1/2 times a sub n minus 1. Notice that a few of the sequences we just looked at continued on forever, whereas others stopped. A finite sequence contains a finite number of terms. An infinite sequence contains an infinite number of terms. We use ellipses, which is the ... to show that a sequence continues on forever with a certain pattern. We can also use ellipses within a sequence to show that the pattern continues. So let's try some. Write a finite sequence with 6 terms that starts at 3 and increases by 8 for each new term. This means there will only be 6 terms in our sequence, and we're going to begin with 3 and add 8. So the sequence would be 3, 11, 19, 27, 35, 43. Now let's write an infinite sequence. Write an infinite sequence that starts at -100, where each new term is half the value of the term before it. This means that we're going to take each term and divide it by 2 to get the next term. So we'd start with -100, then -50, then -25, and so on. Notice it's very important that we use the ellipses, the ... at the end of our sequence to show that it's infinite. So now try to do a few more of the problems given to you on the worksheet. For homework, log into your Edmodo account and take the homework quiz.